Okay, now I can see it.
Okay.
Yeah, your time starts now. You have 10 minutes. Good luck.
Good morning, everyone. Our Team HackOverflow presents our Create-a-thon project, Sorting for Schools. We are part of the deep learning track and chose to go with the climate change and environmental risk mitigation theme. Here's more about our team.
Hi, I'm Charlotte Yang. I'm a rising freshman at UIUC. I live in Braintree, Massachusetts, and my role in the project was model development and data augmentation.
Hi, I'm Maria. I'm a rising sophomore at Dartmouth College. I currently live in Beverly, Massachusetts, and my role on the team was to test and train the model and integrate the model with the demo website.
Hi, I'm Margarita Zeleny. I'm a rising senior at Brooklyn Tech. I currently live in New York City, and my role in the project was a market competition analyzer and presentation development.
And finally, I'm Lily Piasanen, a rising sophomore at the Burley School. I also live in New York City, and my role was main researcher, main market analyzer, and presentation designer. Our wonderful teacher and mentor was Michelle Yang. Thank you so much, Elle, for all of your help.
Firstly, let's go over some of the evidence. Around the world, educational facilities are among the largest waste generators. But 78% of school waste doesn't have to go into trash. Instead, it can be put into recycling or compost programs. When it comes to paper, each ton of recycled paper can save 17 trees, 380 gallons of oil, 4,000 kilowatts of electricity, and 7,000 gallons of water. And recycling just one glass bottle means saving enough energy to power a light bulb for up to 4 hours.
So the problem that we are trying to address is that oftentimes types of recycling, such as plastic, paper, metal, and glass, can be difficult to sort both for individuals and for recycling programs and plants and industry. In schools, this issue is even more prevalent because large amounts of recycling are generated through like all the school lunch that students bring, all the paper that's distributed in classrooms, but it's oftentimes not correctly sorted by type.
Now, let's talk about an experience that one of our own team members has had. Try to envision what this scenario might have felt like as a student. Imagine you've just finished lunch and are rushing because you have a math test soon. As you leave the cafeteria, you throw out your used utensils, but you're not sure where to put your paper salad container. Does it belong in the trash because it still has dressing in it, or in the recycling because it's paper? You look around to see if there are any signs to guide your decision, but don't see anything. Under a time crunch, you put it in the paper recycling bin. After all, shouldn't it be better to put it into the recycling? The answer is no. Once the paper has been contaminated with oils like salad dressing, paper fibers will not be able to separate from those oils. Not only are you late to your test, but that salad container or even the entire batch of recycling has become unusable. These are issues that we face on a weekly basis, which is why we developed our solution.
Okay, so let's check out some responses from our recycling survey. 85% of participants were 14 to 18 years old, with another 11% aging from 19 to 24. This age range was precisely what we were looking for because most folks around this age have either gone to school or still are at school. In terms of current participation in recycling, only 66% take part in their local recycling programs, but 86% think that their community would benefit from a system that sorts recycling. Let's dive into one particular response. So one anonymous participant says a recycling sorter would help to make us aware of how the recycling process works so that we can be more efficient when disposing of waste and increasing our sustainability efforts.
Our solution provides an easy to operate product that can both be used in schools and in offices. The automated recycling system uses image recognition to sort out different materials. While we were unable to create the final physical model, eventually it would be implemented into a physical trash can. A camera would be located at the opening of the trash can. It would scan the item and identify what type of plastic or glass it was. Our goals for the project were to design a product that took away the difficulties that came with recycling for people on a daily basis. We also wanted to be able to improve efficiency and reduce costs when it came to waste. By recycling more efficiently, we can reuse items more often, reducing pollution and saving our environment. With the huge influx of trash we have today, improving our system would make a huge difference on our planet. Our layout is three separate steps. First, our machine learning model will analyze an image or scan the item. Then it would classify as a type of recycling. So it would sort it out to either metal, glass, plastic, paper, or cardboard. and then it would sort the item accordingly. So within our trash can in our final physical model, this would be going down separate chutes, sorting whatever item was thrown into the trash.
So next we have a demonstration of our model, which is a video. And after the video, we also have a website link where you can try it out for yourself.
Hi everyone, this is Team 13. This is a demo of our project, which is a recycling type classifier. So this is the Google Colab doc with our model, and this is just a block of code that will take one image and classify it. So first we can start off with a picture of a bottle, which is right here. It's plastic. And so if we run this, we can see that it correctly classifies it as plastic. Now we also have cardboard. And you can see that it classifies it as cardboard. And then we have glass and metal. Which works, and metal. And then we also have here a piece of trash, which would not be recyclable. But as we can see, our model classifies it as plastic. So it is plastic, it's just that something we can do in the future is to have the model distinguish between recyclable plastic and like trash plastic. In this case, this is trash plastic, but it does identify it as a recyclable plastic, which is something we do need to work on. And then lastly, we have a somewhat ambiguous case where there are two items in the frame, and we'll see what the model does. In this case, we can see that it classifies it as plastic. So another thing we have to work on is being able to deal with having multiple items and the object localization in photos. So like, as you can see, these are all pretty noiseless, like very clear photos that only have one thing in the frame. So a future thing we could do is try to classify like different types of objects when there are other things going on in the image. And thank you.
We've created a rough product sketch of what this may look like when put into schools. It starts off with an easy drop-off for your items. A sensor will automatically see when an item is put in, turning on a camera and conveyor belt. The camera will analyze the item's classification and send it off to the compressor. The compressor will make the item smaller and allow more items to be sorted before it needs to be collected. Then it will go down another conveyor belt. Each type of recycling our model recognizes will have a separate deposit. So when the recycling is collected, none of the types will get mixed together. In general, our goal is to make it simple, but also small scale so that all schools can implement it.
So for our market analysis, let's talk a little bit about our competitors. So like us, there are many other sustainability-minded people that have been looking to use AI for recycling. Here we'll point out some popular competitors. So some of these, as Viola and Sammer AI, are only used in huge recycling facilities. Their product is less focused on individual receptacles and more focused towards making profit off of collecting and selling all these recyclables. The main two that we'll be looking at are TrashBot and Buying. So TrashBot only has smart street receptacles, so they're focused about keeping trash off the streets. There are really only two streams, recycling and landfill, which means they don't sort recycling like we do. The second is Buying. They focus on corporal settings, so much bigger companies that produce a lot of waste. But unfortunately, they cannot tell the difference between different plastics or papers, but we can.
All right, so now that you've heard a little bit about some of our competitors, what makes our product different? Firstly, it's designed for schools or other education environments, meaning that we're considering a very specific demographic of students. We've made our product simple and straightforward to use, so we hope that all students from young elementary schoolers to undergraduates will be able to recycle at school. Secondly, the model itself focuses on different types of plastic and paper recycling, which are some of the largest groups of recycling in education settings. Unfortunately, this is still something our team is working on, but ideally it could differentiate plastic and paper subcategories, such as the 7 plastic types. Thirdly, at the end of the day, we wanted the collection of the recycling to be easy, so that all the recycling doesn't get mixed up, and our physical product to be small scale, so that any school would be able to fit it in a classroom or in a hallway.
And lastly, some next steps for the future is distinguishing between different types of plastic, which we've already touched upon, and also image localization, so where the object is in the image. And that kind of goes hand in hand with the identification of objects in noisy images, which is actually like more realistic in how people would put objects into the sorter in schools. There would likely be things in the background. So being able to identify which thing in the image is the recyclable thing and what type of recycling it is. So we're done.
Thank you for listening. If you have any questions or comments, please let us know and we'll be happy to answer anything.
So maybe I'll start off the questions. Wonderful job. I think that was very well prepared. I just had a question in terms of, so far the demo that you showed was all images with, like you mentioned, one item with a pretty white or just one colored background. Moving forward, if you have, if you're trying to take a photo of something in school, for example, you wouldn't necessarily have that sort of background available. So is that something that you guys are maybe considering for the future, or maybe inside your product you're going to incorporate some sort of white background? What would you do in that case?
I think like in a real like school setting, even if you did do a white background, it would be unlikely to stay like totally white. It would probably get dirty pretty quickly. So I think it would be like better to have our model trained so that it can recognize images with like any sort of background, or like being able to like locate where the object is in an image regardless of the background. So I think that's like a good next step as well.
So you guys did a great job. It's a very interesting product idea. What was the source of your training data set for your classifier?